Welcome back. Now it's time to create these database tables with Kotlin and the Exposed framework and learn a whole lot of things along the way, like Infix functions, how to write DSLs and whatnot. So let's get right after it. Now, before we continue with the schema utils create function from the last episode, just a quick hint, you don't need semicolons in Kotlin. And as you can see, it's redundant. I put a redundant semicolon here. It will compile just fine. Still, it's redundant. You can delete them. And coming from Java, you'll likely just put them there. But yeah, you can delete them. Now, imagine we want to have two tables. We're building an account statements library. So obviously, there's going to be a table called account statements. And there's likely going to be another table called users. So you can link account statements to users. And these are the two tables we want to put in here. So let's say you want to create an account statements table. How does that work? Now, in Kotlin, you have the concept of object declarations, like so, account statements. What's an object? An object is basically a singleton object, so just one instance of a class. And in Java, you can have that with, let's say, anonymous inner classes. But in Kotlin, you can use object declarations. And just checking back, the create method wants tables. So that's a Kotlin specific class. And you have to specify that account statements has a supertype of table. And it's not only that you and make sure the import is right, not the h2 table, but the exposed table. And as you can see, it's not a class definition here, but you're actually calling a constructor here. That's why Kotlin, the compiler says the type has a constructor and must be initialized. I don't want to specify a parameter specific to the constructor because it has a name default value here. So I can just call the empty constructor and that's it. And now I have an account statements object, singleton object, and that will do. And as you can see, the schema utils create method already is super happy to create that table. Now a table obviously needs some columns and you can specify them here because the table class comes with a couple of helper methods. So we can start writing val ID. Imagine you want to have an ID column and the val keyword is just like the var keyword, like in Java 10, but it's a final variable. You cannot change it anymore. And then you have a method, actually val ID equals, and you have a method called varchar, which will simply specify there's a varchar column, give it a name, ID name, and again, what I like to do is saying length 50 instead of just having an int parameter in here, so it's going to be an ID column, length 50, and it's a primary key column. And if you want, again, I would like to do these semicolons, you don't need them, and if you want, you can also extract the type, you can double check. Varchar will return a column string. So you could, in theory, put the type here. Make sure you import again the right class. And you could also read it like so, if without the type freaks you out. Then you have a usage column. You call it usage. That means you bought, I don't know, a new Kindle on Amazon. You'll see that in the usage column. Length 200, nothing too exciting. And now you want to have the link. So you want to have a user ID. And here we'll just take a quick break and create the users table first. And you could do it yourself. You could actually take a break and try to do it yourself. But I'll show you again. You have one table. Again, object, declaration, like so. This time it's going to be quite easy. Let's say you have an integer ID column, not one, but ID in here, right? Let's say it also increments, and again, it's a primary key, like so. You have a name column. Every user needs a name, otherwise he'll be sad or whatever, and it's a long name, so your user can have a huge name. Okay, two tables, and actually down here, let's make Kotlin or Exposed create the users table as well. And now you need the link, and here's where things get tricky or interesting. depending on which way you see it. Let's say the column is obviously, it's a integer column called user ID. And that's fine. And now let's call a method called references. And then we can say users.id. What's interesting here is you have this weird thingy here, references. It has two spaces around it. And what's happening here? That's what we're going to talk about now. Actually, let's scroll down to our user value class. And let's say the user has a method. It's called function freakout. And the user freaks out by spitting out some lines. Something like that. And as always, you just print out the line. Okay, you have a user up here. Let's say user freakout. And guess who's back? Like so, that works. Let's just quickly run our program, see what happens. And you see line equals guess who's back. That's fine. Let's try to write it like the references up here. User freakout, guess who's back? That doesn't work. You could actually think the compiler would be completely unhappy. But what you can see is it says infix modifier is required. So what we did almost worked. And as you can see, as always, I put in the semicolons, remove the semicolon. Let's try something else. Let's go down again and say infix here. Infix fun freakout. And suddenly that works. I can write user.freakout just without the dot. Let's try and run our program to see that it still does the same thing. And you get the two lines without the exclamation mark. So you can see that it actually worked. And it's a nice feature. It's one of Kotlin's nicer features to write DSLs, domain-specific languages. So once you get used to it, it doesn't look weird to you anymore, but references is just an infix function of columns where you can say, well, reference a different column. Now let's see if that is really true. Can you call dot references and then put the argument in brackets? You can. So as you can see, it's the very same thing, which looks more normal to Java developers, but you can also write it like so. References user ID. And obviously, infix functions need a parameter, so you cannot just go, well, I want to infix freakout and do it like so. You'll get a compile message, must have a single value parameter. Doesn't make sense if you just go user freakout and then there's nothing left here. So that's just one thing to keep in mind, but it makes sense, obviously. Now we're almost there. I'd love to actually run our program, but it's already again quite late into this episode. We'll run the program and learn much more about additional language features in the next episode. Congratulations, you again learned a ton of things, but still you haven't executed your program yet. Let's try and change that in the next episode and see what other language features pop up that will delay our progress.